Let's see this minimum genetic mutation Leetcode problem. A gene string can be represented by an 8-character long string with choices from A, C, G, and T. Suppose we need to investigate a mutation from gene string start gene to end gene, where one mutation is defined as one single character change in gene string. That means if there is only one character change, then that will be one mutation. For example, double A double C double G double T to double A double C double G T A. So there is only one character, last character change T to A. So this is one mutation. There is also a gene bank that records all the valid gene mutations. That means whatever we are mutating, all the mutations should be available inside this bank. A gene must be in bank to make it a valid gene string. Given the two gene strings, a start gene and end gene, and the gene bank, return the minimum number of mutations needed to mutate from a start gene to end gene. Okay, so from a start gene to end gene, we have to mutate, and our target is to go to end gene. So we have to find out the minimum number of mutations. If there is no such mutation, return -1. Note that the starting point is assumed to be valid, so it might not be included in the bank. Okay, so a start gene might not be available inside the bank. Okay, let's see the explanation. Here a start gene has been given, an end gene has been given, and a bank where each mutation of the start gene string will be available. So what I have to find out minimum number of mutations from which a start gene to end gene it will reach. So see a start gene is there, double A, C, C, G, G, and T, A. So for each mutation, that means after each mutation, that mutation should be available inside the bank. Only then we can proceed further, or we can mutate it for next step of mutation. So that means we will have to check for each mutation. If it is available inside the bank, then only we will proceed. So what can we its approach? There are total 8 characters. It has been given already. Total, that means length of this start gene and end gene, its length is 8. Okay, and there are character only A, C, G, and T. That means these 4 characters only available there. So that means for each start gene there can be total 32 cases of mutation. That means 8 into 4, 8 length is there. For each character there is 4 mutation possible, A, C, and G, and T. So it can be converted like that. So if we see for first character, it can either go on A, C, G, or T. Like this, for all the characters, it can go to A, C, G, and T. So we have to check for each character of this start gene. That means after each mutation, we will have to check its mutation, and we will check if that mutation is available inside the bank or not. If it is available inside the bank, then we can only mutate for next step of mutation. So like see here, this is the start gene double A double C double G double T, and this is final end gene. So we can check here how. Let's see double A double C double G and double T. So our end gene is first two A are same, so just leave this one. We can check after mutation, but now see here, there is no need to check first two A. Then C to A, so this will be mutated, and it can be mutated in A, C, and G and T all. But here we are saying, that means after this first mutation, what will happen? In one step there can be only one mutation. Okay, that means only one character can be changed in one mutation. So after this, if we put this one A, third character is A, then its mutated gene will be double A, triple A, C, G, G, T, T. Then we will check if this mutated gene is available inside the bank or not. So you just check, this is not available. Okay, as you can see inside the bank, no string is like triple A and starting with TTA. This is triple A, but here it is starting with A. So this is not mutated string. Okay, so this is not correct. So just leave it here. Let it be C, C, and G, G. No need to change T. Now see this T. Here if T, I mutate this one with A, C, G and T. At first check with A. So after A, what will happen? If we change this T to A, then it will become double A, double C, double G, T, A. So this is the mutated gene. Now we can check inside the bank double A, double C, double G, T, A. So is it available there? Double A, double C, double G, T, A. So this one is available there. So that means we can proceed further from this mutated string. Okay. So this is next mutated string. Then we will again check what is our target. Our target is to bring int gene. This is int gene. So again we will mutate this one. How? So now what is our target? Triple A, no? So first to A, it will mutate and check, but it's not available. Then we will mutate this C to A. Then this will become triple A, C, G, G, T and A. So this is also available inside the bank. C, triple A, C, double G, T, A. Triple A, C, sorry, triple A, C, double G, T, A. So this is available inside the bank. And our final target is also triple A, C, double G, T, A. So how many steps? First is there 1 and 2. So their total 2 mutations will be, then only we can get the int gene after 2 mutations. So what is the process to, that means count the number of steps? That means for a start gene, we have to check for each character. That means total there are 8 characters. So for 8 characters there are can be mutations for A, C, G, T 4 times. So total 32 times. For 8 characters we have to check. Okay, for first character we can check 4 times, for second character 4 times, like this till 8 character 4 times. So each mutation we will check inside the bank. If it is available, then fine, then we will proceed further. No two mutation can be same here, no? Okay, and this int gene will also be available inside this bank. So if this int gene is not available inside the bank, then just return -1. That is the case given. But if it is available, then we have to find out total number of steps, how many steps will be there. But if it is not possible, it can be the case now a start gene is also available, sorry, a start gene is given there and end gene is available inside the bank, but there is no possibility, that means there is no possibility of mutation of the start gene, so we can reach the end gene. In that case also it will return -1. Like in bank now, there whatever mutation is necessary, that is not given inside the bank, then in that case also we can't reach on end gene. See, total there are 32 cases, 8 into 4. So after all 32 cases, if we can't reach on this end gene, then that is not possible. Although this end gene can be available inside the bank, but after total 32 mutations of a start gene, if we are not able to find this end gene, then in that case also it is not possible. Okay, just see the code. So here a start gene has been given, end gene has been given and bank has been given. Okay, so at first I will check if this end gene, if end gene not in bank, if end gene not in bank, then in that case we have to return -1 simply. Okay, this is the first case, because if end gene is not in bank, then it should be available in the bank, but if it is not inside the bank, then just -1. Now our main process will start. So what I will take here, I will take one queue, and this is actually a DQ, and I will store here a start gene with its number of steps to mutate. A start gene, and initially there will be 0 steps. See, this is a start gene, we have to mutate, so number of steps will be the for next mutation. So this is queue. Okay, now I will go inside this queue. So while queue, whatever is inside this queue, I will pop this one. So there are two value inside of this queue, a start gene and this 0. So a start gene is the word. Okay, a starting gene, that is a word, no? So I just take word comma steps equal to q dot pop left. So after popping, what will happen? In word a start gene will come and in steps 0 will come here in first step. If it is mutated, then next word will come here in word and steps accordingly. Now what I have to do? I have to check if this word is equal to int gene. If word equal to int gene, then we will return number of steps, corresponding number of steps. This is our final destination, no? Word should be equal to int gene. Okay, if not equal to int gene, then what? There are total 32 cases. So how will it be moved for 32 cases? So for I in range 0 to 8, and here for character in A, C, G, T. There are only 4 character A, C, G and T. Okay. So I will change each position character. That means there are total 8 position. So I will put new word. See how can we change? First position we have to change, then second position, then third position, then fourth position, then fifth, sixth and seven, like this. Okay, and we have to put this ch for each mutation inside on the place of that position. So what we'll do here for word, that is the mutated string. So if we want to change the position here, see, if I take colon I, then that means till colon I, no need to change. But here if it is 0, if it is like 4, then that means till 3 position we can change, but fourth position will not be. Here fourth position is not included. Okay, so that means if we take I, then what will happen? Till I minus 1 position is included and ith position is not included. So what I will do, after this I will put this ch, then again after this word I have to complete this word and I plus 1 till last position. So what will happen there? Till I minus 1 word is available there, and this ch word will be added for ith position, and next I plus 1 word will be added in this new word. So like this, initially if this was, see, if initially this was like double A, double C, double G, double T. So for first position, if we want to change, then what will we put? We will put here 0, this word. If we want to change first position, then what will happen? For A, if we want to change this A to T, then what will happen? Word 0 plus T plus word 1 colon. So what will happen? This result, this will become T A C C G G T T. See, this 0th word is not included here. Before 0 there are no word, and here from first word, from first character till 0th, that means there are no character before 0, and here we are taking up from first character. So before first, that means 0th character will be updated to T. So like this we will update for each character, and we will check if this is available inside the bank or not. Okay, so if new word is in bank, there is no need of age, no. If new word in bank, then what we have to do? We have to append inside this queue. So next byte will be, we have already popped no that word initial. So if we find out new word inside the bank, then we will append inside this queue, queue dot append this new word. Not like this, actually there should be two positions there, no. We have to append new word with its number of steps. So a steps will be plus 1, it will be incremented because after one step it is going there inside this queue. So queue dot append new word comma steps plus 1, and we will remove this from bank because we have already checked there is only one unique mutation should be there, it can't be repeated. Okay, so bank dot remove. Okay, at first we define here one bank set also. Inside this all bank data will be available. So bank dot remove this new word because this mutation already checked. Okay, it's done. So this process will again be repeated. So total 32 times it will be repeated. In 32 times, whatever mutations are inside this bank, we have to append inside this queue and we have to remove from bank. And if whenever we reach to this end gene, then we will have to return number of steps. So this is the final code, and we will return here -1 if we don't get end gene. Just run this one. Okay, accepted, submit. Okay, submitted.